Hey everyone. We're looking at a sample of pyrite. Pyrite is also known as fool's gold, and for good reason, right? It looks a lot like gold, and I think a lot of gold miners back in the 19th century got really excited when they came upon these large deposits of pyrite, thinking that it's actually gold. One way to determine whether or not it is in fact gold or simply just pyrite is to determine its density. So if we look at a graph here, this is a graph that's comparing mass and volume. Notice the volume is on the x-axis, the independent variable, and then the dependent variable would be mass in this particular case. Well, we know we could calculate any of these points to determine the density of pyrite. Um, Density, of course, equals mass divided by volume. So let's pretend that we want to calculate sample A. All right, so that begs the question, well, what is the mass of sample A? Notice mass is on the y-axis. It goes from 0 to 50. It's halfway. It looks as though the mass is 25 grams. Between 0 and 50, 25 grams is the mass. Divided by the volume. Volume's on the x-axis for A is 5 cubic centimeters. So what is the density? Density equals 25 grams divided by 5 cubic centimeters, which gives us a density of 5 grams per cubic centimeter. What I'd like you to do now is to calculate the density for sample B, sample C, and sample D. You're going to pause the video, and after you've calculated all three, you're going to answer this question: how does size affect density? In other words, as the volume of the rock sample gets bigger and bigger, what happens to its density over time? So go ahead and pause it. Okay, welcome back. Hopefully we've learned that sample B's density, like sample A, is 5 grams per centimeter cubed, 50 divided by 10. Sample C also has a density of 5 grams per centimeter cubed, 100 divided by 20. And sample D is also 5 grams per centimeter cubed, 150 divided by 30. What this is showing us is that no matter the size of the sample of pyrite, the density always remains the same. In fact, this line is the line for the density of pyrite, where density equals 5 grams per centimeter cubed. It is the composition of the mineral pyrite that determines its density. So if mass changes, the volume will change accordingly, and they'll change in the same ratio. And as a result, the density will always equal each other. So for this reason, when trying to differentiate pyrite between gold, you can simply calculate the density. And if the density of a sample of pyrite is 5 grams per centimeter cubed, you know it's a sample of pyrite because that is unique to the mineral pyrite. That's it, ladies and gents. Have a good day.